we will discuss about a new topic, which is your gear manufacturing operation. You all know that what is a gear. Gears are machine components which are used to transmit motion and power between the rotating shafts. So might have studied about this gear in your some previous subjects like strength of materials, and if you don't have any idea, then I will also give you some brief idea. And you all know that it is a very important machine element which is used in mostly in all the automobiles, and its function is to transmit motion and power between the rotating shafts. The transmission of rotational movement is achieved between the meshing gears by teeth located around their respective circumferences. We have different types of gears. These are two gears in meshing, and this is a cross-sectional diagram of one gearbox fitted in a automobile. And that you can see there are different types of teeth which are present on the circumference of a gear. These teeth have a special curved shape which is called an involute or cycloid. Depending upon the different type of profile, they have been named as an involute gear or cycloid gears. The function of this special curve is to minimize the friction and wear between the contacting teeth of meshing gears. We can revise it again that this is a journal tooth profile, which is your involute profile, and it gives a proper shape to the gear teeth. This top surface is called the top land, and this is the base which is having this circle which is called Dedendum circle, and above it there is a circle which is called clearance circle. The top land of the other gear just touches this clearance circle, so that there is enough clearance between the base circle of both the gears. They are in meshing, but there is not any interlocking. Then there is an imaginary circle which is called your pitch circle, and all the motion and power transmission takes place at this pitch circle in a line. And then you have pitch, which is the distance between two corresponding points on gear teeth. Then there is a addendum. This is a distance between the top land or the top circle and your pitch circle. And then below it, this is a distance between the pitch circle and your dedendum circle. It is called dedendum. Okay, and this side surface is called face, and below this pitch circle you have the surface which is called the flank, and then finally at the bottom there is a bottom land just like a top land. And then at the pitch circle you have the thickness of your teeth, which is called the tooth thickness. There are two mainly types of teeth profile. One is the involute profile and other is your cycloid profile. If you have basic idea, then you can remember it, that this figure shows you what is an involute profile and how it is drawn. It is a curve traced by a fixed point present on the tangent which is passing on the base circle. So you have a base circle. If you see that if you divide this base circle into equispaced point and then you draw a tangent over it, and then you consider any one point over it, so that the locus of this point gives you the involute profile. Similarly, you have a cycloidal curve. This cycloidal curve is traced by a fixed point on the circumference of a circle which rolls without slipping on a straight line. This is your straight line, and then you have considered a circle, and on the periphery or circumference of the circle you have considered a point. Then you roll this circle on the straight line without slipping. If you consider any point on the circumference of this rolling circle, the locus of the point gives you the cycloid profile. Now there are two different types of cycloid profile, which is called epicycloid profile, and other is your called hypocycloid profile. So epicycloid profile is obtained when the circle rolls over an external circle. You have an external circle and your rolling circle is rolling over the external circle, and the locus of this imaginary points give you the epicycloid profile. Similarly, hypocycloid profile is obtained when this imaginary circle rolls over an internal circle. This is your internal circle, and then this is moving in this direction and also rolling in this direction. The locus of this imaginary point present on the circumference of this rolling circle gives you the hypocycloid profile. Resultant profile will give you the curves, the gears of two different types. One is the involute gear and other is your cycloidal gear. So you see the profile, the difference in the profile of both the gears. This is your cycloidal gear, which is formed by the combination of both the profile. This is your cycloidal profile, and then this is your epicycloid profile. The combination of both the profile give you the cycloidal gear. What are the basic differences between these gears? The involute gears, they are used to transfer motion and heavy load, and cycloidal gears are preferably used for the motion transfer. They are not preferred to transfer the heavy loads. Involute gear profile are easy to manufacture, hence they are very cheap. And whereas you find difficulty to generate both the profiles of hypocycloid and epicycloid in a single gear, therefore its manufacturing is difficult, hence they are costly. However, the teeth are weaker in involute gears as compared to the cycloidal gears. Now there are different types of gears. If you remember that what are different types of gears, so the simplest type of gear is your spur gear, which have straight teeth. They are parallel to the axis of rotation. Then you have a similar type of spur gear which has the internal gearing, and the gears, there is an internal gear which moves around this internally into this gear. And then we have a rack and pinion arrangement. So this rack and pinion arrangement find its application in the steering system, in the vehicle steering system. So this pinion is attached at the rod at the bottom of the rod fitted to your steering, and due to the rotary motion of this pinion, there is a linear motion of this rack which is fitted to the mechanism or linkages to steer the wheels. Okay, then we have the helical gear. Spur gears are not preferred for very high speeds due to limited meshing of gear teeth. However, there are more number of meshing in the helical gear. But the problem with the helical gear is that you find a side thrust in case of this helical gear, which causes the problem in the engagement of the gears. To counter this problem, we use this double helical type of gear, and it is known as the herringbone gear. So the side thrust from both the direction cancels and nullifies each other, and both shafts are in continuous motion, and then you can transfer the motion at very high speed. This is a worm gear arrangement. This is your worm and this is your worm gear. This type of arrangement is used for the higher gear reduction, and it is preferred to reduce the speeds. Then we have this straight bevel gear. This is the case when you have both the shafts which are intersecting with each other, and you have to transmit the power in the perpendicular direction. Then we have this meter gear. In this bevel gear, you can see that you can increase or decrease the speed by increasing and decreasing the diameter, or reducing and increasing the number of teeth. Whereas in this meter gear, you have the same number of teeth, and just you are bothering about transmission of motion and power from one shaft to another shaft. Whatever be the problems you are finding in the spur gear, similar type of problem is solved in case of this spiral bevel gear. And these are most common types of gears arrangements, and used for different application in the automobiles. If you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.